Well, I am back. I had to come into the classroom because my computer died and I didn't have another charger. So here we are. All right, let's go over a few things real quick from our last section. I know this has only been like 2 seconds for you. This is right here. I just looked at this. This is y axis. The y axis is the starting point. The y axis is the y here, and this is the x when we talk about our coordinates. So we want to make sure that in order to know what our starting point is, x needs to be 0. So when x equals 0, y is our starting point. And these are some more notes that you need to write down for the future. All right, we are going to move towards our questions here. Is it possible that Gustavo's account could have had $0 in it in year 0? And the answer to that is simply no. For C, I'm not sure if I went over B, but at the end of the day, I have to go through our graph. Oh, I didn't put what would happen. So B, what would the graph look like if that was true, if it doubled 10 years? Well, what would happen is if in 10 years it went all the way to $1,000, so 10,000, that means 500 years would be 500, that's the same. That means 0 years, you would have $0. So that is what the line would look like, or the graph would look like, if we did Gustavo's prediction. All right, so that's for B. That's what it would look like. And the key here is the 0, 0. That's what makes it proportional. It has to start at 0, 0, just a heads up. So this is what's going to be, I can't grab my pen, proportional is when it's at 0, 0. All right, for C, is it possible that an account could have $0 in 0 years? No. You need to have money in your account in order to make money, which is to gain interest. And if you want to talk about money, if you want to try to see how you can make money with your money, definitely talk to your parents. You can talk to me also if you ever wanted to outside of class. But yes, investing is the way to go to make money with the money that you already have. All right, we're going to go to 425. This one says for the birds. So let me go ahead and just continue down here. 4-25. If you need to make another page, go ahead. I'm just going to make a line just so I can separate things. 425. When filling her bird feeder, Sonia noticed that she paid $27 for 4 pounds of bulk birdseed. Next time, I'm going to buy 8 pounds instead so I can make it through the spring. That should cost 54 pounds. Does that sound right? Excuse my microphone, hopefully. Yeah, so let's go with A. So let's go with $27 for 4 pounds and $54 for 8 pounds. And it says, does Sonia's assumption that doubling the amount of birdseed would double the price, does that make sense? Yes, this makes sense. This makes sense. Why or why not? Because 4 pounds is 27. So by doubling your poundage, you're doubling your value. So it makes sense because doubling pounds and dollars, I should just write dollars, is equal. How much would you predict that 2 pounds of birdseed will cost? So if I wanted to do, 2 pounds of birdseed would be half of 4 pounds. So 27 divided by 2, and when that's 4 pounds, you're going to divide that by 2. So that should be, it looks like I'm really off today, but 2 into 2 is 1, and 2 into 7 is 3.5 per 2 pounds. And LBS is pounds. So just a little heads up on that acronym or the abbreviation. For B, to check her assumption, she found a receipt for 1 pound of birdseed. She decided to make a table. That's great. Let's make this table. Copy this table down. This is for B. Copy and complete the table below. All right, so we're going to copy this table here. And this is pounds, and this is cost. So if at 0 pounds, how much should it cost? Well, did I buy anything? No, so it shouldn't cost anything. So I'm going to make that a 0. We have a 1, we have a 2, 3, 4, 5, 6, and 8. So I'm going to use red to fill in everything else that we haven't had here. So this is 6.75. 4 is 27, and everything else is blank. So we got to think about this. What is happening in the table proportionally as it grows steadily? It's a constant growth. Again, I'll write that down. Constant growth. How is that happening here, here, and so on and so forth as we get older? As we grow more, have more birdseed or grow in value. The one thing here is this right here is very important. This is what's called a unit rate. For every pound of birdseed, I'm going to go ahead and bring that down. This is a note. Every pound of birdseed is $6.75. 75. So that means every time we go up 1 pound of birdseed, it's going to go up in value by $6.75. So that is our constant growth. $6.75. And that's going to be for every single part. So $6.75 and $6.75, that's going to be $13.50. And then you add another one, this one right here, excuse me, I'm going to use blue, is going to be $19.20. So I'm going to put it down right here. Please put that inside your box. Mine's a little small. So that's going to be $20.25. Add another $6.75. That will give you $27 right here. Add another $6.75. That is going to be 30. Oops, come on. 30. 7 and 6 is 13. And so that's going to be $3.75. And make sure you have enough room in your boxes, that's for sure. 6, you should be able to figure these out. If you need to fast forward, please fast forward. And that's going to be 6 is 9, that's 10, so that's going to be 40, 50. And this last one is an 8. Now, if you ever get a random number, all you really need to do is use this number and multiply it by your unit rate. So you can go ahead and do 6.75 times 8. And that is going to give you your answer. So that should be 40. 8 times 7 is 56. Another 0. That's 60. That's going to be 48. 49, 50, 51, 52, 53, 54. And again, you move your decimal. We've done this before, $54. So that's how you fill out the table. How do the amounts in the table grow? So for C, again, constant growth, they grow by $6.75 per 1 pound of birdseed. And then for D, does the table confirm Sonia's doubling relationship? Give 2 examples from the table that show that. And so you need to know how to do this. So we have an example. So for D, it's going to be yes. And so we have, for example, 1, 6.75. And then we have 2, 1350. That is times 2. That is times 2. You're doubling both parts. And then if you did 2 and 1350, then let's go ahead and put 4 and 27. And again, we are doubling our 2. Come on, 2 here, and we're doubling 1350 to get to 27. So that's why it works. All right, Sonia's birdseeding situation. What makes it different from Gustavo's college fund? Okay, so now we need to understand what is the difference between these 2 relationships. So let's go ahead and go to 426. This is important. You need to know what a proportional relationship is. So 426. The difference, and if you had all of these graphs written down, the difference between Gustavo and Sonia is 1, Sonia's graph, which is birdseed, starts where? At, I just randomly do that sometimes, 0, 0. This is where it's very important to know. It's proportional when it's 0, 0. And 0, 0 is right here. It's at 0.0. Yes, I know it's there. So it's 0, 0. That's where it starts at the origin. So I'm going to put that down, origin. All right. So now, what else do we have? Excuse me. What else do we have for our graphs? Well, they both are growing at a constant rate. So I don't think, I mean, they're straight lines. But it says, why does doubling work for one situation but not the other? Let's go ahead and do that. So I'm going to make that 426. Describe how each graph is the same. And so for A, what makes them different? So this is different. And then they are similar because they are straight lines, which is very important, and they grow constantly. They grow constantly. I'm growing by 2, 2, 2. Birdseed, 13.5 or 6.7, 6.7, 6.7. So they're growing constantly. That's what makes it proportional. For B, how do the differences explain why doubling works in one and not the other? The starting point for Gustavo, and feel free to pause the video if you think you know this, and I'm just going to tell you the answer. For Gustavo, it's just terrible. It's just terrible with this pen. Is 400. So if I doubled, it would be 800 after X many years. Doubling works, and it says right here, generally, why does doubling work in one situation, nothing? It's just because of the starting point. You can't double 0. So that's why it's easy to go from like, well, what do I get at 1? Well, whatever you got at 1, then you start doubling. But at 400, if I doubled that immediately after 1 year, it would be like 800 or something like that. So the starting point is key. The starting point for Gustavo is there. So the starting point, it has to start at 0, 0. Must start at 0, 0. So that's B. C, the pattern of growth of Sonia biodiversity is an example of proportional relationship. When two values are in a proportional relationship, if the proportion may be set up that relates to the values. So 0 is 0. That's the first thing. And then 1 is 6.75. 1 is 6.75. Every single unit is going to be 6.75. So that's what we want to make sure we understand. Work with your team to list other characteristics of proportional relationships based on Sonia's and Gustavo's examples. Be specific as possible. So that is going to be, is that C? Yes, C. Proportional. Number 1, starts at 0, 0. Can't stress that enough. 2, grows constantly. And that basically means or a straight line. If it's not a straight line, it's not proportional. Period. Or whatever they say nowadays. I don't know what they say. I hope you got a chuckle out of that. So grows at a constant rate, has to be a straight line, has to start at 0, 0. And that's pretty much it. If it's not straight, if it doesn't start at 0, 0, not proportional. Keep it very, very simple for you. All right, we're going to go on to a couple more problems here on 434, 435 on the next part. But before I do that, let me just make sure our time is looking pretty good here. I don't want to take too much of your time. Ooh, 17 minutes. Yeah, maybe we should stop right there, huh? All right, so I'm going to go ahead and stop right there. I'm going to let you do your homework. I will let you know on the altitude card. I'm going to take a quick look, make sure it's not too crazy. But yeah, this is what you want for proportional. Hope you have a great day. Let me know if you have any questions. Feel free to email me, and I will talk to you soon. Thank you so much. Bye-bye.